So my topic is pH meter. My roll number is BT21 CME 001 and my name is Varad Dabir. Firstly, before we talk about pH meter, we need to understand what is pH. So pH stands for the potential of hydrogen and it is a measure of the acidity or alkalinity of a solution. The scale ranges from 0 to 14. So at 25 degrees Celsius, any solution that is having a pH less than 7 is termed as acidic. A solution having a pH of 7 is called as neutral, and a solution having a pH greater than 7 is called as alkaline or basic. In mathematical terms, if you want to represent the pH, then pH can be expressed as the negative log of H plus ions or H3O plus ions. So now talking about the pH meter, we first talk about its construction. pH meter basically consists of three main components. The first is the glass electrode. This is also called as the sensor electrode. This is the material, this is the component that actually senses the pH of the material. It consists of an AgCl coated silver electrode with a 0.1 molar HCl as internal solution. The bottom of the electrode is made up of a type of glass that is selective towards cations, specifically towards H plus ions. So the difference in the H plus concentration on the inside and the outside of the bulb generates a potential difference, which is then further used to calculate the pH. Next is the reference electrode. This also consists of an Ag or AgCl electrode. It is used to complete the surroundings with the surrounding liquid. And this solution uses a KCl as the internal solution, saturated KCl as the internal solution. It maintains a stable constant potential, and it is insensitive to the liquid that is present outside. So the junction that is provided at the bottom, it is a small opening that allows for the exchange of ions between this reference electrode internal solution and the outside surrounding solution. The measured pH that the meter measures, it is actually the difference in the H plus between the reference buffer inside the probe and the sample solution. And finally, we have the meter of the amplifier. The electronic amplifier, it detects the difference in the electrical potential between the reference electrode and the glass electrode, and then it converts this potential difference to a pH value, which is usually displayed on the screen. So this is the basic diagram of the glass electrode as well as the reference electrode, and we can see the different components of both these things. Now coming on to the working mechanism, to understand the working mechanism, we need to understand how the glass bulb works. So as I said, it is made up of a special kind of glass. These type of glasses are pH sensitive and are manufactured of SiO2, which is connected via a tetrahedral network with oxygen atoms bridging two silicon atoms. So this means that two other oxygen atoms are not bound and they possess a negative charge to which cations like H plus ions can bind. So the H plus ions bind to these oxygen atoms on both the sides of the glass, or both on the internal side and the external side, and they form a thin layer which is known as the hydrated layer. So a difference in the H plus activities on either side of the glass membrane leads to a difference in the number of ion pairs that exist and an imbalance in surface charge between the hydrated layers. This causes some membrane potential that is pH dependent. So when we are talking about an H plus solution, uh, whenever the surrounding solution is acidic, the concentration of H plus ions outside the glass bulb will be higher than the concentration of H plus ions inside the solution. So this means that the outside layer is more positive than the inside layer. So because the number of H plus ions present in the internal solution, that is the HCl, that are constant, so to balance out the charge at the hydrated layers, some of these H plus ions which are present in the internal solution, they go towards the membrane and they bind to it to balance out the charges. So this leads to the creation of free chlorine ions, and this leads to the creation of free chlorine ions. So to bind with those free chlorine ions, the silver that is present, so to balance out the free chlorine ions, the silver electrode that was present, the metallic silver will lose an electron and it will become a Ag plus ion. So this Ag plus ion then combines with the Cl minus ions to balance out the charges, and in the process AgCl is formed. So the electron that are produced in this process, they give rise to a current, and because a current is formed, a potential difference is also formed that is directly dependent on the amount of current that is formed. So next comes an alkaline solution. This is typically reverse of the acidic solution. The number of H plus ions that are present outside the bulb is lower than the number of H plus ions that are present inside. So the inner layer is more positive as compared to the outer layer. So to balance out the charges, the H plus ions, the excess H plus ions that are present on the internal side of the glass, they move out and they go back into the internal solution. This creates an excess of H plus ions and a deficiency of Cl minus ions. So again, to balance out this charges, the AgCl that was present, it dissociates itself into Ag plus and Cl minus ions. So these Cl minus ions, they go out and balance the excess H plus ions that are now present inside the solution, and thus HCl is formed. However, because Ag plus ions are also being formed, so the electrode donates its electrons to Ag plus ions as a result of the potential of the electrode changes. Now we have got the potential of the reference electrode as well as the glass electrode. Now the amplifier needs to convert this potential difference value to a pH value. This is done using the Nernst equation. The meter uses this Nernst equation that is present on the screen, that is E equals to E naught minus 0.0591 log 1 by H plus ions. This equation that is shown in the screen is valid at 25 degrees Celsius and it is temperature dependent, so at different temperatures the value of the constant will be changing. Now coming to the advantages, so pH meters are extensively used in labs for pH measurement. They are used for various uses like measurement of soil pH, then water quality for municipal water supply, swimming pools, environmental remediation, brewing of wine or beer, manufacturing, healthcare, and different applications like blood chemistry. So some of the characteristics which make it attractive to use are: it is simple to use and it does not affect the quality of the solution that is being measured. It has a very high accuracy. The pH meters provide us with precise and accurate measurements. They are more accurate than the pH papers and the titration methods because they use a digital display and a computer system. So the pH meters are also highly portable. The pH meters can be used in a variety of settings, including in labs as well as in the field. Small battery operated pH meters are ideal for taking to different locations. They also provide us with a continuous reading, so pH meters can be used for continuous automatic control of different industrial equipments as well as commercial processes. Now, finally, talking about the limitations of pH meters. First is the cost. A pH meter costs significantly more than the simple titration or the pH strips that we use. Hence, it is suitable only for those who are involved in regular or daily pH measurements. Also, the pH meter is very fragile. The glass tip is very sensitive and is prone to breaking, and so it must be handled very delicately. So, corrosive solutions might also cause damage to the glass, so it needs to be handled well. The pH meter also needs a good amount of maintenance, so regular cleaning of the surface bulb is required, because if this is not done, then deposits on the glass surface will produce some faulty readings which will defeat the whole purpose of the pH meter.